In today's session, we will learn how an industrial boiler works. We will discuss step by step all sections and the parts of the boiler. As we know, a boiler is used to convert water into steam, which is then used in the industrial processes. To make the steam from the water, we have to feed the water into the boiler. We need a water storage tank located near the boiler. Water is fed from this tank into the boiler shell via high pressure pumps. One pump operates on duty while the second pump remains on the standby. These pumps deliver water into the boiler at high pressure, and a check valve is installed at the delivery point to ensure one-way flow towards the boiler. If the check valve fails, the hot water from the boiler shell can flow back into the water tank. Once the water level reaches the high level, the pump stops filling. A water level probe is installed in the boiler shell, detects low level, high level, very low level, and very high level. This probe starts the pump at low level, stops the pump at high level, and trigger alarms and shut down the boiler at very low or at a very high water levels. Two visual water gauges are also available for the operator to monitor the water level inside the boiler. Next, the water is heated. A diesel burner is typically installed in the boiler to burn the fuel and produce the flame needed to heat the water. The burner includes a small diesel pump and a blower to draw the air in. They mix diesel fuel and air, which is then ignited by an electronic spark to start the fire. The diesel burner is connected via pipes to the diesel tank. The fuel is drawn into the burner through a fuel filter to ensure that clean fuel enters the system. Excess fuel returns to the diesel tank via return line. Burner parameters are tuned precisely to produce the correct air-fuel mixture and maintain a steady flame. Now, you might wonder how the water and the burner flame remain separate. To understand this, consider the furnace structure is built within the boiler shell. As you can see that the burner is connected here. Let's remove the burner and have a look inside the boiler shell. As you can see that this big tunnel is called as furnace. There, the heat from the burner travel through this tunnel and come out from the other side. From here, the heat travels into these tubes. This will increase the contact area between heated tubes and the water, and the water will start to boil more efficiently. Next, from the other end of these tubes, the smokes and the heated gases can exit through the chimney hole. This indirect heat transfer ensures that the water and the combustion gases remain completely separated, protecting both system integrity and the operator safety. As you can see now in the wireframe view that the path of the heated gases through the furnace, combustion chamber, tubes, and finally how it exits the boiler shell. Now the burner continues to heat the water. The water converts into steam, and this steam will be collected above the water surface, ready to be used in the industry. Normally a hand valve is provided to deliver the steam to the process area. Now let us discuss the control system of the boiler. Usually a pressure transmitter is installed on the boiler to monitor the steam pressure. A pressure gauge is also installed as a quick reference for the boiler operator. Now the boiler have a working pressure set point. Once this set point limit is reached, the boiler control system will shut down the burner. When the pressure drops below the lower limit, then the boiler control system will again start the burner to make fire and heat source inside the boiler furnace. Now let's discuss about the safety valves of the boiler. No doubt the PLC system is controlling and monitoring the pressure inside the boiler. To stop the burner, and pressure inside the boiler increases above the safety limits of the boiler shell. Then these mechanical valves come into play. These mechanical valves can be adjusted at higher pressure limits, let's suppose at 12 bar. If the pressure inside the boiler increases more than 12 bar, these valves will open and releases the steam into the atmosphere. These valves usually installed in pair to make sure the safety of the boiler. Now let's see the drain valve of the boiler. As we know that in the industries the boiler runs 24 by 7 whole week. Now as the water turns into steam, the minerals in it start to deposit on the inner walls and the bed of the boiler chamber, and it also turns into clinkers and stay inside the boiler. This drain valves opens maybe 4 to 5 times a day for quick 10 to 20 seconds just to drain some water from the boiler, and this helps to improve the boiler efficiency. Draining reduces the risk of internal corrosion caused by settled debris. Now let's see a control panel for this boiler. A PLC control panel in the boiler automates operation like startup, shutdown, and load management. It continuously monitors the parameters like pressure, temperature, and water level and adjusts the actuators accordingly. This ensures efficient, safe, and consistent boiler performance with minimal manual intervention. Now that's the end of the today's session. I hope you liked today's video. We will soon come with another video. Till next time, take care and goodbye.